What I'm going to demonstrate here is the full workflow from the CAD model or BIM model into PypeServer and then out to the machine. And this workflow applies whether you're using a Vernon MPM or the Master Pipe Compact Profiler. It works exactly the same. So what I've got here is PypeServer Enterprise, which runs the machines, and I've also got Revit with a spool on my loaded up. And one of the add-ins is the free PypeServer Connect plugin for Revit. Now we make PypeServer Connect for Revit, for AutoCAD, for Inventor, Plant 3D, Fabrication CAD Map. All of them work the same. They're all free, and they all make it really easy to grab parts from your design tool and send them down to the machine. So I'm going to demonstrate that here with a spool in Revit. I've got PypeServer Connect loaded in, and to select these the parts in this spool, I can either draw a box around them or just click on the checklist. Once I've clicked on the checklist, I'm going to say Export Cut File. What it's going to do is give me the option to either save as a local file, which I can send over the network to the machines, or I can put it on a USB stick and carry it over. Or if you have an internet connection in your shop, you can use our cloud infrastructure to send it, which is the most convenient way. So what I'm going to do is create a project here. If there was one pre-existing, I could just do that, but I'm just going to call this one Lincoln Demo. And because we're in Reno, I'm going to tell it that's our location. And I'm going to give it a friendly name called Test Spool. As soon as I do that, it's going to grab all the parts, it's going to upload them to the PypeServer cloud and make them available to download to PypeServer Enterprise for the machines. Now, it uploaded 57 parts, and that includes the valves, the fittings, the OLEDs, everything in this spool, not just the pipe that we're going to cut. Now the reason for that is we're going to use that information to use PypeServer's intelligence to modify the design with improvements for fabrication. So moving over to PypeServer Enterprise, I'm going to go to the Importing tab. You can see that there's a wide variety of importers that come with PypeServer, including our own PypeServer Connect, which I just described, M Suite, Stratus, Trimble products, Evolve MEP, Acorn. Almost anything you're using, we likely have an importer for it, along with our ability to import flat files like PCF files, CSV files, and step files. So what I'm going to do is select PypeServer Connect, because that's what we exported from. I'm going to go to the cloud. I'm going to select my project, which is called Lincoln Demo. There's one spool in it. There could have been many. And I'm going to import it. Now, it's going to bring in 21 of those 57 parts, because only 21 of those are pipe parts. But it used the additional information that was in the cloud to find the OLEDs that were part of that spool. And it's now referring to the OLED lookup table function in PypeServer to recognize the OLEDs that are on the spool and modify the hole sizes for fabrication. So typically the holes that are created in the model match the set-on diameter of the OLED. But in order to actually fabricate it, you need a slightly larger hole. And slightly may mean 2/10 of an inch to one shop, it may be 1/8 of an inch to another. Whatever that is, you can say for that particular OLED brand and model, you can modify the default size to whatever you want. So it's going to take these parts now and bring them in. And I've checked the scheduled parts box here. So it's not only going to bring in the part designs, it's also going to create one copy of those parts for fabrication. We maintain a distinction between designs and scheduled parts for fabrication because any one design may be used to fabricate multiple parts. So when we bring in the designs, those are the ones that are kept in the database, and in this case, we're going to schedule one of each for production on the machine. All right, so it brought the parts in, and it's going to bring us over to the Designs and Parts tab, and up here you can see all the parts that were brought in. Now that we've got all the parts in PypeServer, I'm going to go over to the Scheduled Parts tab and nest the parts for cutting. So in this case, because we have 4.5-inch pipe loaded on the machine, I've filtered my view to only show me the 4.5-inch parts. I'm going to select them all, and I'm going to nest those parts on a new pipe. Now, because it knows that the pipe matches the part diameter, I don't have to enter that, but it doesn't know the length of the stock that we're using. So I'm going to go ahead and put in 240 inches, and it's going to go and fit those 4.5-inch parts as tightly as it can on that stick of pipe. And if we had a longer or a shorter piece, it would re-optimize for that. Once those parts are nested, it'll bring me over to the Importing tab, where you can see it did a very good job of nesting these parts. There's very little space in between. Most of these parts had plain ends. If they were miters or saddles, it would rotate the parts to mate those miters and saddles together, again, to squeeze more parts out of the same length of stock. Other advanced features include the ability to nest into the dead zone of the machine to minimize waste. Now I'm going to send this nested stock out to the machine for cutting. And I do that just by clicking on the Create NC file and answering a few prompts, including, if I choose, whether to store the heat number of that stick for these parts. If your shop or your job requires the tracking of heat numbers, PypeServer does that. When you put the heat number in, it will add that to the database record for all the parts that were cut from that particular piece. So if there's ever a problem with that particular heat number, it's very easy to go back into the database, find every part that was ever cut with it, and deal with the issue. So what it's doing now is it's generating the G-code file that's going to run the machine, and it's going to automatically transmit it over the network to the location on the machine computer where jobs are loaded. And at that point, you go over to WinMPM, you select jobs, you select the file, and it starts cutting. Because I don't have a machine hooked up here, what I'm going to do is pretend that they were cut, and on the machine what you do is you just delete the file that was sent over, and PypeServer will detect that and use that as a trigger to automatically change the status of the parts to cut. Now once those parts are cut, you can go back to the PypeServer cloud, and you will see in this project, this Lincoln demo project, the progress of the job has been updated in real time. So in this case, we've cut 7 of the 21 parts. The remaining parts that didn't fit on that stick are ready for nesting. All we got to do is tell it the length of the next piece of stock. It'll nest the next set, send them over to the machine for cutting, update the fuel gauge, so everybody in the project can see where you are.